Alright guys, so today we will be talking about radicals. They are fractional exponents. So let's say you have a base to the power of n over m. You can rewrite that in radical form by putting your base inside the radical to the power of n. The denominator, that goes inside the little hook. That's called the index. So let's say we have 4 to the 1/2 power. We're going to rewrite that into radical form. So your base is going to be 4, so make your radical. 4 goes inside. Your numerator of your exponent goes with that 4. The denominator, that goes over here inside the hook. That's going to be a 2. So usually when you have a square root, you won't write a 2 here. It's always assumed to be a 2 unless it's a different number. I'm just writing a 2 here so that way you know where it goes. So what you're looking for is a number that multiplies by itself 2 times to get to 4. So the reason you're looking for a number that multiplies by itself 2 times is because your index is a 2. So 2 times 2 is 4. So therefore the square root of 4 is 2. So let's say we have 27 to the 1/3 power. So we're going to put the radical, 27 goes on the inside. Your exponent is a 1. Your index, this time is going to be a 3. Alright, so you're looking for a number that multiplies by itself 3 times to get your 27. So 3 times 3 times 3 is 27. So therefore the cube root of 27 is 3. So let's say you got 64 to the 1/3 power. So we have our index as being 3. That's what the denominator tells you. That's 3 here. 64 goes on the inside. Your exponent of your, the numerator is your exponent on the inside. That's going to be a 1. So you're looking for a number that multiplies by itself 3 times to get to 64. So that's going to be 4. 4 times 4 is 16. 16 times 4 is 64. So therefore the cube root of 64 is 4. Alright, so next one. Let's say we have the square root of 150. So 150 is not a perfect square. There's not an integer that multiplies by itself to get you to 150. So the way you simplify this is you got to make a factor tree and break it down to its prime factorization. So it doesn't matter how you break down 150, you're always going to get the same numbers at the very end. So 150, I broke it apart as 15 times 10. And then 15 is 5 times 3. 10 is 2 times 5. So what you really have now, after you broke it apart, is the square root of 3, square root of 5, square root of 2, and the square root of 5. So now you're going to go back and look at your index. Your index is that 2 that's right here. Usually with square roots, you won't write this 2. So it's not there really, but it's always going to be there. So since it's a square root, you're going to look for pairs. You need 2 of the same numbers. They would make a perfect square. So 5 times 5 is 25. So the square root of 25, you know it's going to be 5. The leftover parts, you have the square root of 3 and square root of 2. So you multiply them together, you get square root of 6. So instead of writing all this out, you can use your factor tree and do it a little bit quicker. You have a pair of 5s. You're looking for pairs because, again, your index is a 2. So you want to circle your pair of 5s. That makes a perfect square. The square root of 25 is 5, so you're going to put 5 outside the radical. On the inside, you have left over a 3 and a 2, so you can multiply them, and that gets you 6. And that goes on the inside. So whether you write it out and get your pairs like this, or you want to circle in the factor tree, it's fine. You get the same answer regardless. It's a different way of organizing it. Alright, so let's say we have the cube root of 72. So we're going to take a minute, break apart 72. So that's 9 times 8. 9 is 3 times 3. 8 is 4 times 2. And 4 is 2 times 2. So it doesn't matter how you break down 72, you'll end up with these same 5 prime factors. You end up with 3, 3, 2, 2, and 2. So this time you're looking for 3 of the same thing. So you have a cube root. So I'm going to write it all out just so you can see that step. So we're looking for 3 of the same thing. Cube root tells you need 3 of the same thing. So we have 3 2's right here, so we'll circle them. That becomes the cube root of 8. Cube root of 8 is going to be 2. So we have 2, And then now we're going to put the pieces that we didn't circle back together. So 3 times 3 is 9. So our answer for that one is 2 cube root of 9. Or if you use your factor tree, you would come over here, circle your 3 of the same number. Your group needs to be 3 of the same thing. So you got 3 2's. That goes on the outside. The leftover part goes on the inside. So you got 2 3's left over. So the radical doesn't ever change. You have a cube root here, so that stays as a cube root. So then 3 times 3, that's 9. That goes back inside. So let's say we have the square root of 96. So take a minute, break it apart. 12 times 8, and then 12 is 6 and 2. 6 is 3 and 2. 8, you get 2 and 4. 4 is 2 and 2. All right, so I'm just going to do it based off of this factor tree. So our index for this one is a 2. So we're going to come here, circle pairs. So we got a pair of 2's. We also have another pair of 2's. So right now we have 2 pairs of 2's. So they both go on the outside. So you would have 2 here, that represents one of the pairs. You have another 2, that represents the other pair. So you multiply those together. And the leftover piece you put back on the inside. So 2 times 2 is 4. On the inside you have 3 times 2 is 6. 4 square root of 6. And let's try one more on this slide. Cube root of 1080. So break apart 1080, and then your index is 3, so you need 3 of the same number to make a group. So I did 10 times 108. 108 is 9 times 12. 9 is 3 and 3. 10 is 5 and 2. And then just keep breaking it apart. Alright, so after you break it apart, you're looking for 3 of the same exact number. So right here, see how you got 3 3's? You want to circle that. That's one group. You also happen to have another group of 3 2's. So that also gets circled. So they both go on the outside. On the outside, you would have 3 times 2. And on the inside of the radical, you would have 5. So your answer is going to be 6 cube root of 5. So make sure you have the little 3 here as your index. That doesn't disappear. Alright, so let's try the next one. Square root of 256. So try to break it apart and see what you come up with. Alright, so I got 2, 128, 2 and 64, 8 and 8, 4 and 2, 2 and 2, and then 8 you can break apart into 2 and 4. 4 breaks apart into 2 and 2 again. So you're looking for pairs. So since it's a square root, you need 2 of the same numbers to make a pair. So you got 4 pairs of 2's right here. So a pair of 2's and 3 more down there. So they all go on the outside as one individual 2. And that's 16. Or if you know that the square root of 256 is 16, you can skip all that and get to here. Or if you don't know that the square root of 256 is 16, break it down, make a factor tree, and that goes there. Alright, so let's say we have letters on the inside this time. We have the square root of x to the 4th. What we're going to do with this is use the rule that we had on the first slide. B to the power of n divided by m becomes m as your index, b to the power of n. So this becomes x to the 4 divided by 2. And then we're going to go through and reduce this fraction. So 4 divided by 2. Don't forget that if there's not a number for your index, that's always going to be a 2. It's always a 2 unless it's another number. So 4 divided by 2 is 2, x squared. So the square root of x to the 4th is x squared. So let's say we got the cube root of x to the 7th. We're going to take that, change it back into a fraction. So we have x to the 7 over 3. We're going to reduce that fraction. 7 over 3 is the same thing as 2 and 1/3. So change it from an improper fraction to a mixed number. So 7 divided by 3 is 2, and you got 1/3 left over. So what this means is you're going to have x squared, that's outside, and then the x on the inside. So this is just showing you long division in case you forgot. Alright, so again, you have x squared and x 1/3. So the x squared is the whole piece on the outside, the x 1/3 goes back on the inside. You're going to change it from exponent form to radical form. Another way you can do this is you can list down the x 7 times. So x to the 7th power is x 7 times. The index is 3, so that means you need 3 x's to make a group, a whole group. So you got 3 here. You got 3 more there. So you got 2 groups of x's. That goes on the outside. It's x squared. The leftover part remains on the inside. All right, so let's do one more example and call. So let's say we have the cube root of x 10. So I'm going to write it out 10 times, and then I want to circle groups of 3. There's 1 group, 2 group, 3 groups. So you have x cubed on the outside. Leftover is x on the inside. Or you can take it, divide it. So 10 divided by 3 is 3 and 1/3. So on the outside you would have x3, the x 1/3 you put back on the inside. That's x1 inside the cube root. Alright, so we will do one more example. So let's piece everything together and combine all of the concepts that we've been doing. So let's say we have the cube root of 48, x6, y7, z8. You know how to do them individually, so we're going to break it apart and do them individually. And then at the very end, piece everything back together. So we got the cube root of 48, cube root of x6, cube root of y7, and the cube root of z8. So take the 48, break it apart, simplify that first. So since it's a cube root, you need 3 of the same number to make a group. So you got a group of 3 2's, that goes on the outside. The leftover parts you multiply and you put back on the inside. With the letters, I'm going to go through and divide it. So 6 divided by 3, that's x squared. There's no remainder, so it's just x squared. The next one is y7 divided by 3. Or another way you can do the x's, again, is if you want to list them all out, you can. Circle your groups, you got 2 whole groups. With the y's, 7 divided by 3 is 2 and 1/3. So that means you get y squared outside, and on the inside of the cube root, you get y. Or if you want to list it all out, you get 2 groups and 1 left over. Same with z. 8 divided by 3 is 2 and 2/3. So z squared on the outside. Inside the cube root is going to be z squared as well. You can list it all out. You got 2 groups and 2 left over. Alright, so now the last part after you do them all individually is you're going to go through and organize it. So all the pieces that are on the outside of the radical, you put together on the outside. So you have this 2 outside the radical, you have x squared, you also have this y squared, and you also have a z squared, that's from here. Inside the radical, so the cube root just comes down as cube root, you have a 6, you have a y, and you have z squared. Alright, so hopefully that helps.